Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Synopsys with Chun Chan, who's going to talk today about reverse debug. So, Chun, what is reverse debug, and how does that compare to standard debug?
Okay, so reverse debug is mainly for people doing test bench debug. And if you look at the traditional test bench debug, people do interactive debug. And in the interactive debug, you can only go forward. And reverse debug allows you to go back in time.
And so, what's the advantage of that?
The advantage of reverse debug is if you look at traditional debug, if you missed the point that you want to debug, then you have to go all the way back to time zero and then start all over again. So you can imagine that if your debug point is like say second half of your simulation, that is actually pretty painful to go all the way back to time zero. So reverse debug can allow you to go back just like small step or as big steps as you want to the going backward in time.
Why don't you draw this out for us?
Sure.
Chun, what are we looking at here?
Okay, here on the board, right, we draw the two scenario. The one on the top is a traditional interactive debug, and you can see that, typically people will set a breakpoint somewhere closer to your point of interest to debug. But of course, you don't know where this point is, so you can only approximately showing where to stop. Okay, once you are at the breakpoint, you will do the step forward. And unfortunately, in most of the time, people will miss the point that they are interested in because they don't really know where it is, right? So what happens in the traditional debug, when you find out you missed, you have to go all the way back to time zero. And then in reverse debug, you can see that when we do a step forward, and then we miss the point that we are interested, we can either choose to go back a smaller step, go back in time, or you can choose to go back, further back in time. Depends on where you guess where the problem is, right? And then you can start try again.
So, you're dealing with a lot of data here, right? And what you're trying to do, more or less, is bookmark where you are and be able to come back to that bookmark.
That's correct. So under the hood, what the tool does is doing the checkpoint or the managing the checkpoint for the user. So it's completely transparent to the users. The user doesn't need to worry about it, and the tool will determine where to restore your checkpoint and then move forward again.
If you didn't have this kind of checkpoint, what would you have to do? Go all the way back to scratch and start all over again?
That's correct. So if you don't have this checkpoint, just like the traditional debug, if you miss the point, you have to go all the way back from here to time zero and then start all over again.
And this allows you to transfer this kind of knowledge across an entire team too, right? So you don't have to do everything with one person. You can now say, okay, we ran into a problem at this point. Everybody look from here to here.
Yes, that's correct too.
What else can you do with reverse debug? What are some of the other advantages?
Okay, so one very neat features in reverse debug that you can do is sometimes when you go back in time, you kind of guess, what the problem is and then what might be the fix, right? So reverse debug allows you to go back in time, and in addition, you can sort of change some of the condition of your simulation and that allow the simulation to try out your guess. So that's what we call a what-if analysis.
Why was this not done in the past? What was the problem? Was it just not complicated enough where you needed this kind of automation, or was it just because nobody ever did this kind of stuff?
And first of all, I think the important or the fundamental of this technology rely on the tool is able to manage all these checkpoints nicely so that it becomes transparent to the user. So one thing that you can imagine that you don't really know where your problem is when you do the checkpoints, right? So you need to have a tool to be intelligent enough to know that, okay, where do I put this checkpoint and how do I arrange it strategically so that you would not dump too much data and then slow down the simulation too much. So that is what prevent people to be able to provide this kind of technology in the past.
And also the chips that you're designing are significantly more complicated in many ways. They're more heterogeneous. They're down sometimes at smaller nodes or in advanced packages. You've got dependencies that you didn't have before. Now all this has to be looked at in terms of use cases, artificial intelligence, how that's going to play out in the field, right? Mm-hmm. This is all brand new.
Yes. So, with the test bench, just like what you said, right? With all these new technology or AI chips and different scenario, the test bench itself become very complicated. So you really need to have a way to help you to manage the data and then to help you to do this interactive debug, because the test bench itself is more like a software debug rather than the traditional HDL debug.
Are we actually saving time in terms of bringing chips to market? Are we getting more reliable chips as a result of this?
So the what people get from this technology is your test bench is much more reliable. So it basically help you to develop your test bench better, and then you can verify your chip better, and then your end product is better.
So you have more confidence when you finally get the sign off before it goes to manufacturing.
Exactly. So because you know now your test bench is doing the right job, and then it's testing your design in the right way, and then you have more confidence with your product.
So a lot of these designs are in a state of almost constant flux. So we're developing things change along the way. Can you do things like what if analysis? If you change something, what's the impact of that?
Yes, that actually is a very good point. Even these days, right, the design getting very complicated, and your test bench also getting very complicated. So if you are not able to do the what if analysis, that will slow down your entire verification process. So what happened is, if you try to debug your test bench, right, and every little things that you want to change, you need to go back and recompile your simulation. Sometimes it will take you, a couple of hours, and then rerun the simulation and try the things again. So what if analysis gives you the ability to not recompiling the simulation, but just roll back in time and then change the condition and then move forward again.
If you do the what if analysis and you do change something, do you have to go back and do all the debug again, or can you now say, here's the marker where we changed something, now we go forward?
That's exactly what if analysis provides you. You don't need to change everything, but only go back in time and then to look at the points that you would like to change, and then adjust the condition, and then allow the simulation to move forward again.
Chun Chan, thanks
Yes.
for a great explanation.
You're welcome.